Okay, today I have a chance to talk to somebody. I've bumped into him at trade shows a couple of times, but he's somebody that most everyone in the modular world's going to know. His name's Scott Jaeger. He is the big brain behind industrial music electronics. Uh, for those of us who've been around the modular world a while, we would probably recognize it more as the Harvestman. But he does very unique modules, ones that kind of have a very unique visual space too. And so you can the kind of modules you can identify from across the room. Very sharp looking and kind of has this iconic knobs and stuff that make it really, really stand out. But a really interesting set of modules, and I was really excited to have him join us for the podcast. So with that, I'm going to say hello to Scott. Hey, Scott, how's it going?
Hello, it's going good today.
Thank you so much for taking the time to have a chat. I really appreciate it. My understanding is you just got back from a trip to Portland looking after some manufacturing, right?
Yes, my modules are manufactured in Portland exclusively by Dark Place Manufacturing. So the nice thing about that arrangement is I am just north of Seattle. So if I'm taking a lot of expensive or heavy parts, it's usually a lot cheaper for me to just take a drive down there and see my friends and drop the parts off rather than send a UPS shipment down there.
Yeah, sure. That makes a lot of sense, right? Well, and you also get a chance to hang out in Portland, which is such a beautiful place.
Oh, yes.
What is it that you've got going to manufacturing?
Well, it's a new module that should be out probably second week of August, realistically. It's called the Argos Bleak, and it is a control voltage processor that simultaneously controls four oscillators. I like to call it the world's most expensive octave switch, but it is, if you can imagine, two calibrated control voltage inputs taking 0 to 8 volts, such as what comes from a keyboard or a sequencer. And you have four rows of knobs where you may quickly assign the octave shift with a twist of a knob, as well as fine tune, vibrato amount, and slew amount. There's onboard vibrato and slew generators. And really, it's meant to tie together the behaviors of four oscillators that may or may not be from the same manufacturer to quickly behave in a very controlled way in response to a set of input control voltages. Now, to make that a bit more interesting, I've set it up so that you can program semitone offsets for each of the four output channels that happen pre-quantizer. And then those and other channel settings may be stored as presets and CV'd through. So effectively, it becomes a chord generator if set up correctly. And there's also a series of gate and trigger inputs at the bottom, such as the quantizer trigger in and out for behavior like the well-respected Doepfer A156 quantizer,
Hmm.
a gate for turning the slew signals on and off, and the thing I think that really ties the module together is the input swap gate input, which will change up the assignment of what input gets routed to which output channel. For example, you can have input A or B, A plus B, and the gate will change that in a predictable way. So it's a means of temporarily overriding your sequence with manual keyboard play, or simply really screwing up your control voltages experimentally with a single gate signal.
Well, that sounds really interesting because it's sort of to do that kind of functionality now with your typical module set is actually kind of a pretty big chunk. I'm just trying to, in my head, I'm kind of like thinking if I were to patch that up with my existing system, the number of different modules that would have to get involved just to pull off even part of it. So that's kind of cool that you're bringing that all together in one sort of front end processor.
Yeah, it just makes it very quick to set up and repeatable for those who like to perform tuned musical activities using their oscillators.
Right. Now, it's interesting you say it that way too, that it's like around performance because one of the things I notice is a lot of people that perform live with their modular systems, tend to have a lot of your modules in their system. And I'm not. I mean, when I look at the modules, I find them compelling, but I'm not sure why it is that they've become such a staple for performance. Right? I mean, are you a performer yourself?
I've really not had the time to do so since the company has grown a little bit, but
Hmm.
I would love to perform more. Actually, the greatest motivator of any of my modular designs is live performance, more
Uh-huh.
so than circuitry or the algorithm.
Well, that's interesting because it clearly it that's clearly somehow like subliminally communicated because well, and I think too some of the issue is like the way that you do the controls, especially with those big bright orange knobs, it really does make it so that you can quickly identify where you're at. And also because each module has a very unique layout, you can even kind of like again almost subliminally you know which module you're going after because each one has a clearly delineated layout, right?
Right, that's absolutely correct. What I try to do with each module is make it so that the knob layouts are quite different from module to module, and they're different sizes, widths, and heights of the knobs. I believe I'm working with 6 different knob sizes now, with the idea being to your hand can feel which module
Right.
is underneath it without needing to read it. And the controls, I almost never put things in a grid arrangement or repeat more than 5 elements in a row, so that if you've practiced with the module for a couple days, then you will most likely understand the natural locations of each of the controls and the I/O. So you don't have to read the legend on the faceplate once you've practiced with it for a little bit.
Right. Now the other thing I remember from sort of like when you first started working with stuff is you were one of the first people to be willing to use sliders on modules, which when it made sense, and I thought that too gave a really there's some real clarity in having certain parameters be slider based rather than knobs.
I agree. I was kind of limited in my use of sliders in the very earliest days of the company when I was still hand building things and using a manual hole punch to prepare the face plates. Uh, some companies that deal with the metal photo process have since offered affordable machining services as well.
Hmm.
So, and immediately as I got access to that, I started redesigning certain modules and replacing knob controls with sliders because I am a big fan of whatever designer at Roland decided that ADSR envelope controls should be sliders
For
instead of knobs.
sliders, right?
And of course, for sequencers, the Time Safari Mark II was redesigned as a result of my ability to use sliders, as well as the Piston Honda Mark II. You can move as many sliders as you want with one hand motion, where you can only really turn 2 knobs at once that way.
Right.
So there are certain parameters that are very appropriate for slider control, and I've thought quite a bit on that topic.
Now, when you first started the company, it was called the Harvestman.
Yes.
Why did you change it? I had a number of people asking me to get you on the podcast, and as part of that, they all were like, "Find out why he's not called the Harvestman anymore." So, if you
Well,
could explain.
the company itself was started in 2007 as a result of some projects I did as a graduate student at Northwestern University. Those were some very early versions of my first modular designs, such as the Malgorithm Bit Crusher and the Zorlon Cannon gate generator. And that project came about because my friend Theron and I were playing in a large improv jazz group, and we got some access to some modular equipment there, both through the school and the increasing affordability of the Doepfer A100 system. Our tastes really turned towards sounds and processes that weren't really represented in the modular space. So the Harvestman was more of a personal project that came out of my own academic work there, and then as well as sound material that was generated that way. But it kind of carried over as soon as I got out of the school and was immediately met with requests from a certain retailer to produce a number of these devices. So the name for the personal project stuck with the company for some time. The change to industrial music electronics started about 2.5 years ago. And that's when I felt that the maturity of my Mark II line had gone. I was more confident in my abilities as a designer and engineer. And that's when we made the decision to start the design of some guitar pedal designs and other ancillary devices. And our manufacturing setup had been solidified with our cooperation with Dark Place. And also my aesthetic tastes have changed a bit towards, shall we say, industrial, both in reference to a ages-old musical movement and that of industrial processes themselves. So I thought it was a good time for a change to represent our greater abilities in product design and, the addition of the pedals. It's not just a modular company anymore. I thought it was a nice time to shake up the entire identity of things. And 2 years later, I think that's finally settled in.
Right. What's interesting is you kind of talked there a little bit about the getting started process for the company. One of the things that's come up in a number of my prior interviews is people talking about your entry into the module making thing is the thing that spurred them into believing that they could do it, right? Because when you first started producing modules, you were kind of, other than, I mean, Doepfer was doing his systems, but at least to me, it seemed like at that time, in that 2007 timeframe, nobody had really identified Euro as the thing, and there wasn't really any other third party manufacturers much to speak of at all.
At the time when I started designing things, modular Eurorack modular was obviously the most convenient platform to develop instrumental ideas because the mechanical and electrical specifications were very well documented, and of course the modular nature of the devices themselves just invites that kind of experimentation and design. But yeah, at the time I think there's Doepfer, they're the two British systems and solutions manufacturers. Mike Brown and Peter Grenader had their companies then operating together as the Ear Group. There's Vox Glitch. And other than that, I'm not sure of a whole lot of people operating as organizations. A couple DIY things here and there. Of course, Frack Rack was more of a concern at that point. At the time I started designing in 2006, it was there wasn't a whole lot of a scene. Most of that was driven by Livewire, Plan B, Ear Group.
Yeah, and other than Livewire, most of that stuff was pretty plain vanilla stuff. I mean, the things that Plan B was doing and the things that in Doepfer's offerings at the time were sort of like different versions of what earlier Roland modular systems had kind of been, right? And so then I imagine you coming out with something like the Malgorithm, just sort of everyone was like, "What the hell?"
Well, it was nice to exist in the same design space as those guys as I was learning how to do things. As soon as Mike Brown of Livewire caught wind of some of the things I was working on, he treated me to a very long phone call where he gave me a great set of advice about how to manufacture these things, some tips for doing business with certain people, things like that. His own designs were greatly influential on me. For example, the different knob sizes, the relation of location of a control voltage input jack to its attenuator, which is a huge thing that I don't think it's fully sunken in among the greater sphere. Now, the Livewire designs there are certain things that were nice, like the Chaos computer, which finally saw release some years later. Yeah, the Plan B stuff was pretty nice because it was we were still in the mid 2000s. There's still a point where the works of Don Buchla, West Coast Synthesis, designs like that were really not all that documented, much less available for a lot of musicians to use. So a lot of Peter's work, I think, was really important in making, things like the low pass gate or an oscillator with a nice sounding linear FM process. That was really important to make that accessible to musicians, and that very quickly became part of my vocabulary as I was designing instruments for myself.
Right. Well, and it's interesting you mention oscillators, though, because that, to me, when you started doing sound generators, is when, at least in my recollection, you really came onto everybody's radar with the Hertz Donut and the Piston Honda. Those two seemed to be, that seemed like when those things came out, that seemed to like be in everybody's rack then.
Mm-hmm. Yeah, the very very early on, as soon as I realized that I had the ability to develop ideas that could become modules, obviously the killer app would be a wavetable oscillator with the same sort of aggressiveness as, for example, the Waldorf Microwave 1 or the Prophet VS, where the transitions between wavetables just has that bite to it. And I think in 2009, that's when I was able to actually realize my first stable digital oscillator designs and offer them to others.
You ended up developing sort of a full range of modules so that you could basically have an entire system based off of your modules. Did that at the time seem like an important goal, or was it just something you wanted to do for you, or did you really feel like there were holes in the market at the time that you needed to fill?
Well, for the Mark I series, that one was a bit different because some of those were my very first designs as a engineer, synthesis designer, and a lot of that I was learning as I was going along. And when I would need a new project to do, I would look at a different synthesis function that I haven't really thought of, and I would pursue a project if I could find a sort of character interface or other way of operating that wasn't adequately represented by things that were actually available. Now, there wasn't a lot of modular out there in those days. It was my reaction to the availability of other things was primarily against, things with keyboards that only generate musical events in response to key presses or MIDI signals and don't actually directly respond to physical displacements like control voltages. So my own path of learning there was dictated by what I haven't done before and what really hasn't been explored in a certain way so that I may fill a hole for my own personal use. Now, as skills solidified and I redesigned many things for the Mark II series, there was a much greater thought given to system level design. Now that my modules were able to behave more consistently from one to the next, the new graphic identity was chosen at that time to neatly separate the various controls into functional blocks and have their associated analog inputs and outputs relative to those controls. And at that point, I had also achieved full fluency in what control sizes I should use and what controls should have sliders. And we found some nice illuminated push buttons, which unfortunately only available in red and green color. But yeah, with the Mark II series, that's when things became thought of a lot more intensely as a system. And my own collaboration with Vladimir Kuzmin on the Polivoks series, known as the Iron Curtain Electronics. We had since redeveloped the schematics of the entire Polivoks instrument at that time as a modular system. So we were able to get the full series out then. And of course, the graphic identity, locations of certain controls were all consistent from module to module at that point.
Right. So I'm going to want to talk about the Polivoks experience in a little bit, but before we do that, one of the things that actually surprised me when I was doing a little prep research is that you were a music major in college. And so this all of this development, and now you've kind of talked about it too. This development came from a desire for a musical result, and then you learned the electronics necessary to do that, right?
Yes.
This is a fascinating area of discussion for me because I certainly, I was a musician long before I played with electronics. I found electronics very intimidating, and it didn't sort of follow the same logical functions that I was used to in the rest of the world, right? And so I really struggled in trying to learn electronics. Now, certainly when I tried, there was a lot fewer resources than available now. But I'm curious what your path looked like in moving from being a musician with some interest in gear to being what you would, I mean, it sounds like you would now legitimately consider yourself an analog engineer, right?
I have some analog skills, and in the background, I'm working on legitimizing that engineer part of things.
There you go. What's the path that you went through to get to this, to the point you are at now, to sort of like the level of maker that you are now?
Well, as a kid, I was never really all that successful in building radios or anything like that. I didn't have the best tools available to me, but I think the biggest first step was when my older brother received a Casio SK1 and a Sensonics drum for Christmas in 1986. And as he reached adulthood, he moved out and left those things behind, and they became mine. Right around the time that I've discovered Reed Ghazala's wonderfully written article about circuit bending the SK1. That single document is probably the biggest influence on me in really digging beneath the faceplate to manipulate the stuff beneath it. So, of course, I circuit bent that SK1 and others that I collected, and that's when I really got the confidence of really just attacking a circuit in a really crude way and enjoying the results that came from that. Of course, I had a taste for the types of sounds that would result from that. Now, in 2005, I'd I'd started experimenting with microcontrollers, the PIC 18 series, and you know, I thought about things like controlling old video game sound chips. My skills weren't up to that at that point, but for the first time, I discovered that my projects were powered up correctly and working. Just some trial and error, experimentation. So I started writing very simple things in assembly on those PIC chips, and after the summer, I was able to get back to Northwestern and make a large project out of that, which resulted in the world's first voltage-controlled bit crusher, the Malgorithm.
Awesome. How did your university advisors feel about you taking that on?
Well, the large project was in the second year of my master's program. My advisor was Gary Kendall, who in the past he took a leave of absence from his post at Northwestern to form a corporation that produced a 3D sound device using the Motorola 56K series. And sometimes in our talks he talked about that whole experience, but surprisingly, he was really excited to sign off on that project and just turn me loose, fleshing out anywhere from 1 to 4 designs, and as a means of really pushing the idea of voltage-controlled digital signal processing, as well as the interface concerns of a modular instrument that exists in hardware instead of, for example, a super collider program. I think that was interesting and different enough from the business as usual at that point that the department seemed to be happy to see me exploring that way.
It's interesting to me that you actually had advisors that were interested in it, because in a lot of cases, music departments, especially big ones like Northwestern's, can be so I'll use the word Catholic, right? They can be so Catholic that anything outside the norm is just it's not viable for them to even know how to talk about it.
Yeah, at Northwestern, there was at the time quite a conflict between the orthodoxy of the administration and other departments and the real weirdos that we had in music technology and composition.
Hmm.
I suppose I should mention Chris Mercer as well, who came on as a lecturer right around the time that I joined as a graduate student. And he was very interested in the performance of feedback processes, and my time with him was also very influential in developing my own feedback console arrangement of modules, such as quad pedal amplifier that's normal to a matrix mixer, which feeds its signal back into the high gain guitar pedals. We had a really good time doing a experimental music course where undergraduates were encouraged to play with contact mics and other transducers to generate very organic performance processes. That was probably a high point of my time there.
Well, I can see though too how that would sort of have influenced your thinking and eventually getting you to make put together the kind of processors that you had, because you actually got to see some of that functionality in action through a lot of different people.
Mm-hmm.
It sounds interesting, and but it also sounds like you're a really self-driven person. So you never really got any electronics education in any kind of traditional route at all, then, right?
I took an electronics course in high school, but that was at a time of extreme misbehavior. So myself and my classmates didn't really pick up anything beyond what we already knew from our own activities at home. But yeah, the electronic side of things is mostly self-educated, and I've been fortunate to have certain crucial projects work correctly early on, so that I was motivated to continue with more complicated things.
Well, I'm writing down the phrase "a time of extreme misbehavior" because that is a that's like a magical phrase, because I think it's something that everyone can remember the point in their life where that would have been a great identifying sentence. That's awesome.
There are these large wooden desks, right? And with large drawers that may be 10 inches tall, 18 inches deep, and those DC power supplies went up to 40 volts. So, it was, for example, a daily ritual where we'd take some long leads from the power supply and put them into the drawer and find the largest electrolytic cap that we could find, reverse the polarity, and enjoy the popcorn smell that would happen after you could hear the pop down the hallway.
It's yeah, it's funny you say that. I think that in fact anybody who thinks that they want to get into electronics, one of the first things they should do is just reverse polarity on a capacitor and just see what happens when, first of all, it blows up and a piece of metal goes flying across the room and you get that smell. And you're either going to be like, oh my God, I never want that to happen again. Or you're going to say, that's interesting. I got to get into this a little more, right?
Yep. And then there's, of course, the rite of passage where you get zapped, and with the assistance of the voltage, you toss your tool farther than you would be able to normally.
Right, exactly.
I mean, musculature is apparently capable of some wonderful feats of force, but sometimes I guess the brain isn't really up to that peak performance.
Right.
It takes the direct current, I guess.
That's great. That's one. That's one I haven't had the chance to do yet, but I'm also not looking forward to it either. So maybe that's where I hit my limit with electronics. Now, one of the things I wanted to ask you about, well, there's a couple of things I wanted to ask you about. First of all, this idea of doing voltage controlled digital processing. I mean, the piston Honda and the Hertz donut kind of were like the sound generating parts of that, but you also did like the time Safari, which was sort of like kind of a crazy looper mech system. Obviously, the algorithm doing its digital craziness. What was it that drew you to the digital side of it specifically? Again, was it just something that was different from what everyone else was doing, or did you find your voice in that digital analog combo?
Really, I prefer the sounds of a lot of digital processes. You can't really touch the aggressiveness of a roughly shifting wavetable morph, or certain bitwise operations on audio streams. Stuff like that really can't exist with analog circuitry, not without extreme measures taken. And
Hmm.
yeah, the lack of availability of musical instruments that allow you to quickly reach that point. Like I like a lot of sounds of the digital keyboards of the late 80s and 90s, but once again, they have organ keyboards attached, and they're really only slowly responding to digital commands. And the idea of real-time control is afterthought. I came up during the era of the $150 wave station, which I thought was a great learning experience. And I've had cheap Prophet VS as well, collection of microwaves that no one wanted. But I think I also became more familiar with guitar technique starting around 2005, and the number of dimensions that you can affect the sound with just two hands is really, why can't you do the same with an electronic device? You can program a patch with your envelopes and your modulators and everything, but as far as the real-time control and everything, I don't think that's yet reached its maximum. We're still thinking in things of, how many knobs or sliders can affect this thing, instead of how can the system inside this device or this module, how can it be more readily opened up to respond to environmental phenomena? Most of that being through your chosen controller generating control voltage. But I see these modules, even if they're digital, they are physical systems that must be made to properly respond to their environment, much like a vibrating guitar string.
Most people that feel the call of that end up focusing on trying to build new control surfaces. So I while you were talking about that, I kind of looked over to the one wall of my studio where I have a push and an Ovation circuit and a Rolly squishy keyboard and regular keyboard and a mono button box and stuff like this. And I realized that a lot of people who kind of hear the call of expressivity try and make a control surface. Is that something that you ever played around with?
Yeah, I've played around with a lot of concepts off and on. A lot of things kind of dead end themselves. That the whole, imagine a very wide panel that may or may not sit inside a modular rack with, nicely chamfered cutouts that fit the shape of the human hand, things like that. I've had better ideas since then, which will happen at some point. But I really like, and other manufacturers have represented this quite well, I like the feel of the force sensing resistor if you take the old quarter-inch thick mouse pad material and attach to that. That's my favorite touch technology right there. I think along those lines.
Because I was wondering if you were ever drawn to anything like Bukla's, the Thunder. That was, I don't know, that didn't have the kind of response. You're right. In a way, the amount of effort that has been put into like touchpad technology, because they sell zillions of them, right? So the amount of effort that they're putting into that is clearly pays off in a extraordinarily responsive device.
Yeah, I've drawn my share of Thunderbird-shaped finger cutouts, and I'm sure a couple of us have, but I have a better idea now that hopefully I'll be able to realize next year.
Well, that's great. I'm looking forward to seeing what you come up with on that. Another area that you're well known for is this work on the Polivoks series, which and you do it under the moniker of Iron Curtain Electronics, right?
Yes.
Could you explain more fully, first of all, where that comes from and the person that you work with on these designs?
All right. Well, Vladimir Kuzmin is a Russian electronics engineer who worked for it was a state radio factory in what is now Ekaterinburg, way out in the Urals in Russia. I'm not sure what his initial tasks in that factory were, but it came upon him to lead the teams that would design the musical instruments. So they did things like organs and amplifiers and string machines. But in 1982, they completed the Polivoks, which was the first fully voltage-controlled instrument in the Soviet economy. Those were available to cultural organizations through the shop system there. There are other designers that made some voltage-controlled synthesizers in Russia, but I think the Polivoks was the first and the most complete as far as resembling what we know as a voltage-controlled synthesizer. Now, due to the system there, these were military factories, primarily building radios and other electronic equipment, but the finest electronic parts were reserved for the strictly military applications, of course. So the way I understand it, they kind of had the leftovers to work with, which explains, first of all, the really interesting nature of some of the electrical mechanical components like the rotary switches and the way that the knobs are fixed to the pot shafts. That's really interesting. If you ever have the opportunity to do a teardown of Polivoks, I highly recommend it. It's an otherworldly experience.
It's an education, huh?
The design of the electronics themselves, I believe, was influenced by the limited selection of parts. The voltage-controlled filter works in a very unique way in that they're using some programmable operational amplifiers. They're using the programming pin to change the bandwidth of the amplifier itself. So there are no external capacitors in the filter core. And that's what leads to the really unstable feedback characteristic of that filter design. And they thought on that design for quite some time to arrive at the character that I want. But in the end, it was very simple. 2 operational amplifiers, 6 resistors, and then all the stuff around it to realize the voltage controllability. But the core itself is the 2 op amps and 6 resistors.
Yeah, it explains it sounds different than anything else. It sounds a lot different than anything else, and that explains it a lot.
Yeah, they did have access to whatever foreign patents they wanted, and like other instruments like the MS-20 that visiting musicians would bring in. Like they'd borrow the MS-20 for a night and see how it worked. So Kuzmin and his team were very well aware of how synthesizers work and some of the things that they can do. But in their own designs, they were forced to come up with some very clever solutions to common problems. Like the oscillator is, there are no tempcos in there. So they use negative temperature compensation using a heated transistor array and pretty gnarly looking stack of resistors and trimmers. But that oscillator design is as stable as any other well-designed VCO, and there are other such clever things all throughout all the circuits that I've looked at. I mean, in some cases they could be inspired by Western designs, but there is a distinct quality and character throughout most electronic instruments I've inspected that have come from the Soviet bloc.
Sure. Now it's mind-boggling to me that there was a Soviet synth at all, because we now have got this mythology of what the Soviet Union was like, and all we can imagine is, people standing in front of gray buildings hoping to get a loaf of bread. And so it doesn't seem to align with the idea of getting synths made, but of course, society was society, and so they had to do things. These things that they were making, were they generally like given to other, like radio stations or universities, or was it kind of like an official government issued kind of a device? I assumed it wasn't like, hey, musicians, come on by and get a synth.
The way I understand it, first of all, the Polivoks is priced so that it was a month or two salary for the average Russian. So it was explained to me that the average Russian probably wouldn't be able to go and buy it in a store. I'm also not familiar with how these things were distributed into their shop system once they left the factory, but I know that the greatest customers of the Polivoks were cultural organizations and bands with state backing,
right?
Things like that.
Sure.
I know that there are a whole bunch of really weird Russian stomp boxes that kind of look like DoD pedals, for example, but different. There are other less expensive instruments. There seem to be a full selection of electronic or guitar instruments of any type, but I suspect that the availability and the economy of them was quite different from what we're used to.
Now, when did you first run across a Polivoks? And you're kind of well known for like enjoying an aggressive sound, and you said as much during this chat. And the Polivoks would certainly then speak to that kind of internal voicing. But how did you run across one in the first place? How do you trip across an old Soviet synth?
I'd actually not encountered one in real life until several years into my operation as a company. What happened was Sean Cleary of Analog Haven he really wanted a Polivoks module to exist. I was familiar with the Polivoks circuit itself just through my enthusiasm for synthesizers in general, as I learned about them, how to play them, how to design them, and eventually through his efforts to have someone or anyone make a Polivoks filter module. I was just coming with my Bit Crusher at that time, which he also wanted to buy, so he suggested that I begin a collaboration with Vladimir Kuzmin, who is a friend of his. Sean lived in Russia for a time, and he very generously set up that arrangement, and it's turned into a very fruitful collaboration. Now Kuzmin and I work on adapting some of his circuits to guitar pedals where appropriate.
Sean Cleary, he's like the Pied Piper of the whole modular thing. Again, the number of people that point to his influence on helping them get started has been pretty amazing.
Yeah, he tries to have his irons in the fires.
That he does. So now you're working with Vladimir. What is that collaboration like? Does he work on the circuitry, or do you collaborate on the circuitry, or does he just have his designs that he wants to run with, and you just help realize them as a product?
Well, sometimes we talk about ideas. He has a whole library of ideas that he's either personally designed himself or stuff that's fallen into his hands after the collapse of the factory system at the end of the USSR. He comes up with ideas of things that could sound interesting or things that he's designed that he's never actually listened to before, such as the sub-octave circuit that we produce that sounds amazing. And usually it happens like if we can agree on something that might work as a modular pedal, he'll drop a modernized schematic that uses the old Russian parts where appropriate and substitutes modern components to make the thing manufacturable otherwise. And then what I do is I draw upon my own experience as a modular player and designer, and I modify the interface. I do the front panel design. I arrange the controls in a meaningful way. Sometimes I change the law of the controls so that there are greater sweet spots in the big knob travels. I add attenuators and range switches so that it makes more sense as a module rather than something that was once part of the keyboard. So our collaboration kind of happens that way. We do certain things and then we pass the work back to one another for further revision. Usually his schematics are great. It's his idea as far as what the circuit does, so I don't often suggest changes to that. What I do is mostly interface related, which I think is the most pressing thing that must be addressed in any modular design, regardless of what the circuit does.
Well, that makes a lot of sense, though, to me, because what I was going to suggest was that despite the fact that two designers are responsible for the circuitry, other than the different language used on the front panels, there's a sense of these all being of a thing, right? And so that speaks to the fact that you've got your hand in that interface design. And again, a very performative interface.
I've tried to arrange the controls such that it doesn't matter what language the panel is in. If you practice with it to get your preferred range of sounds out of it, you shouldn't have to read the thing. That was inspired, as we've discussed before, I like things that aren't in a grid. I like knob layouts that you can feel, like certain knobby synthesizers I've enjoyed in the past. My favorite ones have had different constellations of controls, like For example, the Axel Hartmann's Andromeda constellation, I think, was brilliant and a welcome departure from a lot of the stuff that he's done in grids.
Yeah, that's a fact, and it's a great point. Now, you talk about venturing into the world of guitar pedals. What are you finding different in that world than you've experienced in the modular world?
I see that most guitarists play the pedals as sort of a set and forget thing. A lot of my early experience playing guitar pedals without a guitar and self-feeding feedback operations, made use of the front panel controls as a performance element.
Mm-hmm.
I've since becoming more aware of how the thing is played. I see. I don't know. It's hard to quantify the differences in how the controls must behave between a module and a pedal that do certain things, but I feel that the applications are entirely different and they must not behave the same.
Right. Well, and also in a guitar pedal, you're generally not going to get away with something like, oh, I don't know, the layout of a Hertz donut, which has like 2, 4, 6, 8, 9 knobs on it and switches and a whole bunch of jacks. That doesn't really work in a pedal format, just from a layout standpoint or an accessibility standpoint, even.
Yeah, I see that now these days, expression pedals are still quite a popular thing, and that's the preferred interface to real-time control of stuff, where the expression, a lot of times in more interesting pedals now, you see that expression signal can be routed to one or many parameters, and that's how that's accomplished. The main controls with the really pretty knobs on them are set up to provide a nice baseline, and then the expression pedal and the guitarist's own interaction with the vibrating strings determines how that circuit will affect the tone.
Now, you talk about how you kind of grew up around the more standard synthesizer keyboard kind of thing. Have you ever been tempted to try and make a black and white keys, orange knobbed polysynth or anything like that?
I've fleshed it, at this point in my career, I've fleshed out a couple full instrument configurations, if you can call it that. There's one collaboration where it was suggested that there be an organ keyboard attached, to which I felt kind of allergic to that idea. But, for a company as small as mine, we have a staff of 4 people here, and it's a bit hard to organize larger projects that scale. So all of my more integrated designs have been collaborations with other people. For example, we're working on, and we call them the 4-voice synthesizer groove box that I'm doing with Moleco, things like that, where there's 5 times as much hardware on the panel, and the circuitry and the power supply demands are much higher than a modular. So yeah, I've had ideas. I've come very close to finishing a bunch of them, but no, especially with the health of the modular market as it is, I think I'll be focusing on that for a little while. And really, this state of the market at the minute is something that I've been dreaming would happen for a very long time now. At last, modular patching and all the nice experimental devices that come along with it seems to be fully legitimized as what electronic instruments are, what the building blocks of the things that actually make the sound are. They're finally abstracted as modular units, and no longer are we subject to a larger company's marketing department telling us what kind of circuitry is or isn't too expensive to put in an instrument. Now there's a healthy community, and it really is a community of smaller companies trying all kinds of crazy ideas and digging up old or unfashionable technologies to make really interesting things. And most importantly, the musicians that take the risk to learn how to use these expensive devices, and finally making the kinds of real-time performances that previously only available to instrumentalists such as guitarists. With modular instruments, you have immediate control over so many dimensions of the sound, and with an adequate control setup, you may perform it fluently as well as anyone else. Like the act of performing electronic music is, it's not tied down to a sequencer or whatever your workstation of choice is. Now it's like anything else. It's an object that makes sounds that may be directly influenced in any number of ways. And I'm really glad that there is now a market that actually supports this idea to exist and is healthily growing.
Well, it's interesting you say it that way too, because I'd never really thought about it that way, but because I've always thought of the real value of the modular thing as giving you the ability to make your own idiosyncratic instrument. And I think that's important, but you point to another thing, which is if you compare what someone doing a modular synthesizer based performance, how they're performing, it's a lot more like a guitarist than, say, a Jean-Michel Jarre or a Kraftwerk kind of performance, right? It's not that staid, kicking off a sequencer, playing the organ style keyboard and stuff like that. It's much more hands-on. It's like sloppier and dirtier in a way it's very not tied to a keyboard and a discrete on and off switch kind of a thing, but it's a lot more loose and greasy, like playing guitar. I never really thought of it that way, but that's so true.
Right. The oscillator is oscillating whether you want it to or not. And
Right.
I think this, over the last decade, the development of small format modulars is something that's accessible to many musicians. I think we just may arrive at the point where the Nord Modular G2 is no longer the high water mark of our musical civilization.
Right. Yeah, well, it is an interesting thought, and again, you've kind of opened my head to thinking about things in more performative terms. I really like that. Now, I'm curious to ask you what you're about to produce this the Argos Bleak. What are some of the things that you imagine for the near term future? Maybe not exact products, but like categories of things that you think represent the near term future, because it seems like you have a very clear vision of what you would like to see the musical world do. What do you think, how do you think that translates into product like ideas?
Well, I'm with the Mark II series, those were written in C with a nice compiler, so they're actually maintainable. And I'm always learning new tricks about things as I design new modules and fix problems with old ones. Stilson Hammer is a good experience because everyone uses it differently, and my users provide the most useful bug reports and feature suggestions to me, so I'm constantly on my feet with that one. But some of these designs are 5 years old now, and what a modular is to people has changed a bit in that time. And the expectations of modules in my price range has also changed. So certain ideas get refreshed. But the nice thing is the hardware of the old modules is capable. And some of the things I've learned, a lot of old things are currently undergoing some pretty substantial improvements. Like I'm doing a complete rewrite of the Time Safari so that its pitch shifting behavior is better, loop resolution is finer. I hope to produce some more of those someday. Like the hardware on that one is great as is. The firmware could stand to be improved, stuff like that. More stability on the Kermit. I have general ideas that I'm thinking of lately is, for things that load audio files or other data, it's not such a bad idea to have very limited displays or being able to read files off of a SD card, for example. So I think further ideas, my modules are going to cost what they do simply because of how they're manufactured, the amount of metal that's on them, and the amount of controls there. The guts really don't add all that much to the cost in some cases. So I've been thinking of more elaborate designs like that. And most importantly, the algorithms are what they are. They can be improved over time if it's a digital device. The most important thing to me is that the interface makes sense, is unique. You can feel it with your hand. You can see it in the dark because of all the LEDs. But most importantly, one control per function, no menu diving, stacking. The thing does what it says on the panel, and that's that. We give the user an idea to work with, and that's what that particular piece of hardware does. So with that, I've learned a lot in the last decade, and I hope to issue a series of modules over the next year that represent that experience, that's more closely tailored to what the users would like to see in its performance capability. And Stilson Hammer has been a great learning experience for that, because we're always adding new features or tightening up little bugs that we never would have discovered otherwise. Our dialogue with customers is really good these days, and it looks very positive going forward, especially with the health of the market as it is.
Well, that's fantastic. I'm looking forward to seeing what more you bring to the marketplace. But just as you continue to tweak these things, it's really exciting to watch. Scott, I want to thank you so much for, again, taking the time out of your schedule. I know that you've got a lot going on at all times, but taking this time to talk, I really appreciate it, man.
Well, thank you.
All right.
For having me on your wonderful podcast. And as I look through the archive, I'm going to have to listen to a bunch of these things myself.
All right. Well, I'm looking forward to hearing your feedback on that. So with that, I will let you go on with your day. Thank you, and have a good one.
All right. Thank you.
I want to thank Scott for the great chat. It's really interesting to hear where he's coming from, how he's gotten involved in the Polivoks stuff, and just in general, how he views the world of creating a performance interface for modular users. I love it. Thanks so much for continuing to listen. Thanks for sharing this with your friends. And hang on, we've got more great stuff coming. Talk to you soon. Bye.